Hacking with Pandas. In this tutorial, I will show you many of the tricks that I use with Pandas library to create Proficient solutions. If you're a beginner, you may be well familiarized with the dummy solutions that I will develop, and if you apply the hacks that I give you on the Proficient solution, you'll become a better programmer. We'll solve many questions such as query with multiple conditions, filter the rows, regex flag, filter axes with regular expressions, and the many ones that you see on this notebook. Without further ado, let's get started with masks of the Boolean array. We need to filter the year 2021 in this data frame where we have also the year 2019 and 2020. The dummy solution would be to ask the data frame in the column year, is it equal to 2021? They will give us true and false that we save into a mask of the year, and we pass this mask of the year to the data frame with the brackets to filter out the rows where the year is 2021 as we put on the condition. We execute, and there we see a data frame with only the 2021 year. Instead of writing 2 lines of code, we could have done it in 1 line of code if we would have used the function query. For example, year equals to 2021, which is the same that applying the mask, but in only 1 line of code. We execute, and there we see the same data frame with the year 2021 as we saw before. The next exercise, query with multiple conditions. Filter the year 2021 and aeolic technology. We already did for 2021 in the dummy solution. We will copy the previous solution, paste it here, and now if we want to add a new mask such as the DF energy in technology that can only be aeolic, we save it as well into a mask, and now we add it to the brackets with the ampersand, mask aeolic, and there we have the year 2021 and technology aeolic. Again, we could have done this inside the query function by just applying query year equals 2021 and technology equals aeolic, and we must alternate from single quote to double quote inside the query. Aeolic, we execute, and there we see the same solution we saw before in 1 line. Filter rows with regular expressions. We want to find all fiats from the following data frame. We have the column of the name of the car here, name. The dummy solution would be to find all of the exact names of the car inside this column, but there are almost 400 rows. It's not the most efficient solution. So what else could we do here? We can apply regular expressions. This is, we get inside name, then we access the string properties, and inside the string properties we ask contains fiat anywhere, because fiat could also be in the middle of the word. We execute, it gives us true or false, that we can use it as a mask for fiat, and then when we get inside the data frame with the brackets, we can see only the fiat cars, instead of manually creating a list with the exact names of the cars, which is very time consuming because we would need to see all of the rows 1 by 1. Now the next question is X flag to ignore case. We want to select all sports cars from this data frame. We have the name in the last column. The dummy approach would be to ask inside the name column if there are cars that contains sports. We create the variable mask sports. We pass it to the data frame that we want to filter, and we don't see any car because they might be named with the capital letter. If we want to make sure that we cover all of the situations, we can do export all capital letters, and export only the first letter. We execute, and there we see the solution. But sometimes people misspell the word by using the capital letters where they should not be. Is there a way to use ignore case? Yes, we have the flags that by default we don't have any, but in the documentation we can see how we could use ignore case from the regular expression library, RE. So we copy the solution, we just use export, the flag should be from the library re, ignore case, now we execute, and there we have the same solution, and saving time because we had writing export just once instead of 3 as we did before. Moving to the following exercise, filtering the axis with regular expressions. Now we are using the function setIndex to put the name instead of the last column as the index of the data frame. Therefore, to access the name of the car, I cannot use name because it's not a column. It's just the index of the data frame. It's on another level. So we access the index, we go to the property of the strings, we ask if it contains the fiat, we can use the flag re ignore case, we execute, we get the boolean mask of the fiat, and now we access inside the data frame for the fiat. Now instead of using this long way, we use filter. They have the regex parameter to look for the fiat, and very important the axis because we will look in the index, the 0. So we use regex equals to the fiat and axis equals to the index. We execute, and there we have all of the fiats in this data frame with just one line of code instead of using this dummy solution. Let's move on to the following exercise. The data frame order matters. If we execute this line of code and we have the technology that generates the energy and the generation in megawatts per hour, we want to visualize the data frame with the bars. We import the Plotly library, and then we use the function bar. They ask first for the data frame. We use DFF. In the X we use technology. In the Y we use generation megawatts. We execute, and there we see the bar, although we would prefer to reverse the axis to see them better. Nevertheless, the technology aren't sorted by the generation. That's because in the data frame DFF, we don't have the rows sorted by the generation. We look for the function sort values, ask for by, which is the column we want to sort, in this case generation megawatts. We execute, we save the variable again in DFF, and now we visualize the previous line of codes. We execute, and there we see a sorted chart with the technologies that generated more energy at the top. To see all of the technologies, we could increase the height of the figure. So height equal to 400, and there we see all of the technologies. Also, in case that you run in troubles because of the order in which you sort, you may use the parameter ascending false when you sort the data, and you will see that they will plot it on reverse order. So far so good. Now let's move on to the pivot tables and the group by, which are the differences. We want to summarize the generation megawatts by technology and month. In this case, with the DFF, we group the data by the technology and the month. Then in generation megawatts, we calculate the sum, and we transform the resulting object to a data frame with the function toFrame. The visualization of this table could be improved if we leave the months by the index and the technologies in the columns so that we can see the full perspective. Instead of using the function group by, we can use the function pivots table. They will ask for the numerical column where we want to apply the mathematical operation, the sum, the column where we want the categories to be in the index, and the categories we want to be on the columns. So values equals to the generation megawatts per hour, index equals to the month, columns equals to the technology, and the aggregation function will be the sum. We execute, and there we see a better result than the previous one. If we go to the following question, we will see that the dummy solution is to leave the table as it is, but we could highlight the most significant values with a background gradient, giving colors. Therefore, we can use the style property of the pandas. Inside, we access the background gradient, we execute, and there we see the colors for the most significant values on each column. We could leave the table as it is, but there are too many decimals, so we'd better use a function to have just 2 decimals. So we can use the function format and then giving a precision of 2. As a general advice, I would try to put these lines of code line by line. So I would use the data frame, then the style property, and the format on the other line. And finally, I put the other bracket. Now let's move on to the following exercise from absolute to the thousands. For example, we could leave the visualization as it is in this cell 500,000 megawatts per hour, but since we are counting the data by the months, we could have them in gigawatts per hour. In other words, we could divide by the thousands. To develop the solution, we only need to divide by the 1000 with this line of code. Div 1000, and then we execute. And there we see how we got 500 gigawatts per hour instead 100,000 megawatts. In the following exercise, specify the darkest value. We could leave the table as it is, but the darkest value is the highest for each column, for each month. Nevertheless, we would like to highlight the darkest value as the highest value among all of the values in the table. To develop the Proficient solution, we need to understand how the background gradient works. We have the parameter axis that by default is 0. This means that they will highlight based on the highest value of the column. If we put 1, it will be the highest value of the row. But if we want the highest value among all of the cells, we shouldn't take into account any of the axes. So axis equals none. We execute, and there we have the highest value to be 7,000. The darkest one. We could say that the technology that generated more energy in a single month was aeolic in the first month, January. And last but not least, change the color palette to the topic theme. The energy is normally associated with the orange because of the sun. To develop other colors in the table, we could use the parameter CMap, which is the map of colors, and by using oranges, they will change the color to an orange gradient. There are many others, for example, blue to red, and we now see the lowest values in darker blue, whereas the highest value in red. If you want to know more about the color palettes that you may use from Matplotlib library, you can go to Google, Matplotlib, CMap. In this website, you will see the names of the color palettes: Viridis, Plasma, Inferno. because there are different types. They are classified diverging, cyclic, qualitative, miscellaneous. For example, we can take ocean, and in the Python codes, we can put ocean, and there we have another color palette. As always, it is not enough by just watching the video, you need to put in the practice, so take another dataset and apply the ideas that we have taught you in this tutorial. If you want to join our academy where we provide you other datasets to work on weekly challenges, please let me know in a comment of the video and I will tell you the instructions to join the academy.